When designing an algorithm to meet some goal, one approach that we can take is, rather than trying to think of how we could get to that final big goal, instead think about a single step that we could do that gets us slightly closer to that goal. And then we can perform that step over and over again that gets us slightly closer, and eventually all the way there to whatever our goal was. And so what I want you to think about today is a single step, and you'll notice that I don't say single operation like x equals 3, but a single step that could be a little more complex than that we could do to be slightly closer to having the data shown here being sorted. So the end goal is for it to all be sorted. But what's one small step that we could take that would get us a little bit closer to having the data sorted? One approach you can take is you might think about if you had these physically in front of you. What's one thing that you can do, one change that you could make that would make it slightly closer to being sorted there? So pause the video and think about at least one single step that you could take to have this data slightly closer to being sorted. So there are a few approaches that I want to describe. First, I'll eliminate some. So we'll eliminate any step that doesn't consistently get us closer to having the data sorted. So if you had these on cards, for instance, shuffling until the data was in order does not count for us here, because we have to be one small step closer every time we do it. So one thing that often comes to people's minds when I ask them this question is to swap two items that are out of place. Out of order in relation to each other. Like the 5 and the 2. So we could take that list that we had here, and we could instead have 2, 5, 1, 10, 7. And that's a little bit closer to being sorted because the 2 and the 5 are now in the correct order relative to each other. 2 is lower, so it should come earlier than 5. Another approach that often comes to people's minds is to pick the lowest value, the minimum, and put it at the start. So that we would look through that list of data there, and we would find that 1 was the lowest, so why not put it at the start? And we could do lots of different ways to get it there, but let's just switch it with whatever's at the start so that we have 1, 2, 5, 10, 7. And then another approach that's a little more complicated to explain, but that sometimes comes up in these, is to find the correct location for one item and put it there. One way that people can sometimes do this is by counting how many items ought to go before it. So if we took 5, we could go through the list and we could find that there are 2 items that ought to go before it, so we know it should go third in the list. So this is a little harder to explain, but another approach is that we could maintain a list that's partially sorted here so that as we insert things into that partial list, it would all be in the correct sorted order relative to each other. We insert into this list in sorted order so that we inserted 5 as the only item in the list. Then we would insert 2 into the correct place in that smaller list. We would then insert 1 into its correct place in that smaller list. And then when we go to insert 10, we would insert it at the end, and so on. So this is another approach that, again, is a little more difficult to describe, but could definitely get us to a sorted result. So these are all valid single steps. And it turns out that each of these is the single operation in a known sorting algorithm. One where we swap two items that are out of order over and over until the whole list is sorted is called bubble sort. And that's the one that you'll examine in section A of the activity today. Picking the min and putting it at the start, well, you're selecting something, and so that's called selection sort. And then finding the correct location for one item and inserting it there, that's referred to as insertion sort. And so this shows us that we can take a single step, one small operation, one small move, change, and get ourselves closer and closer to having our goal achieved of having the data sorted. And so we're going to look at when we choose that single step, what's its performance? And then when we do that step over and over, what's the performance of the overall algorithm? And we may also see some neat behavior patterns along the way as we look at our activity for today.